All right, Algebra 1, moving along with systems of equations, looking at some more applications of it. We've been doing some application of it already. Today I just want to kind of wrap that together right here. How do you choose the best method for solving a system of linear equations? I've been telling you all along as we go along, like you want to graph them. If they're both in the y equals mx plus b form, it makes it real easy to graph them. Plus you got graphing calculators. If one of the equations is an x equal or y equals, then substituting would be a better way. And if they're both in standard form, 2x plus 3y equals 7, and they're both like that, then the elimination method works best. So let's take a look at some of this. If you look at problem 1 on page 406, it tells you that you have a fashion designer, makes and sells hats. The material for each hat costs $5.50. He sells the hats for $12.50. He spends $1,400 on advertising. How much must he make in order to break even? We've talked about this before. Break even is when expenses and income are the same. Okay, you've made or you brought in as much money as you spent. Okay, after that you can start making a profit. Well, we got two things we don't know here. So two equations, two unknowns. First unknown, x, will be the number of hats that we sold. Okay, because that's the question, how many hats do you have to sell in order to break even? So y is going to be the amount of money we bring in, whether it's an expense or an income. So when we look at our expenses, that cost was $5.50 per hat in material, plus the $1,400 for advertising. That's money he has to put out. Okay, the money he brings in on his income, that y is $12.50 times the number of hats that he sells. He's bringing in $12.50 for every hat. Okay, so we've got them both in the y equals form, which you could graph both of these, but that's a little big to be having to work on the graph. You could plug it in the calculator and do it, but I'm going to use substitution. I'm going to set them both equal to each other. So when I do that, since they're both equal to y, I'm going to substitute that into that y. So I'm going to get 12.5x equals 5.5x plus the 1,400. Subtract this over. So we get all of our x's on one side. So this cancels out 0. I get 7x equals 1,400. Divide out the 7. X equals 200. He's got to sell 200 hats to break even. Okay? So that's one application of it right there. And I did it by substitution. If I graphed them both, that would have been the x-coordinate where I crossed at. If you want to know how much money that break-even point is, you can plug it back into either one. You could take, whether it's expense or income, they're equal at the break-even. You can take that $12.50 and multiply it by the 200, and I believe you're going to get 2,500 bucks. That's the break-even point. Okay. So when he gets to $2,500 of expenses and he sells his 200 hats, he'll have $200 in income, or $2,500 in income. He'll be at break-even. Okay. So that answers that one. Let's look at another example, problem 2. Whoop. Technical difficulties. We can work with that. All right, problem 2. Dairy farmer. He produces low-fat milk containing 1% fat and whole milk containing 3.5% fat. How many gallons of each type should be combined to make 100 gallons of milk that is 2% fat? Okay, so I got two unknowns here. They asked us to find how much of each. So I'm going to make x equal the number of gallons of low-fat milk, and that's 1%. And how many gallons of whole milk? That's 3.5%. Okay. What combination of that will give me 100 gallons of 2%? So we need 100 gallons of it, so x plus y equals 100. However many gallons of x of low fat and however many gallons of the whole milk that he puts together has to total 100. Okay, that's the first bit of information they gave us. Then we're going to look at the percentages. We're adding 1% milk, so many gallons of it, plus 3.5% milk, and you'll notice I made them both decimals. You change your percents to decimals, equals 100 gallons of 2% milk. Okay, so from here, it's up to you how you want to solve it. Okay, I'm going to take it and do this. Since I got x and y's on the same side, I'm going to start out by multiplying by 100 right here, so I get rid of my decimals. So when I rewrite these two, I'm going to get x plus y equals 100. 100 times here is going to be x. 100 here, move it 2 places, I'm going to get plus 3.5y, and that's going to equal 2 places, 2 times 100 is 200. Okay? Now, if I take that second equation and multiply it by -1, boom, 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 I'm going to get that right there. Change the signs on everything. The x's will cancel. 1 minus 3.5 is -2.5y. 100 minus 200 is -100. Divide out the -2.5. You better take care of your signs here, because you have to get a positive here. We can't have negative gallons. So this is going to go in there 40 times. So I'm going to get 40 gallons here. That leaves me 60 gallons of the 1% milk. Okay? And if you think about it, 2% milk, that's closer to 1% than 3.5%. So we're going to need a lot more of the 1% to bring that 3.5 down to 2%. Okay? When we start mixing it. So there's 2 applications right there. Again, you could solve them any of the 3 ways, but the way they got set up, I just thought it was easier to do elimination here and easier to do substitution on the other one. So we've been doing stuff like this. We'll look at some more of this, because again, you know, where do you use this stuff? Well, these are opportunities here to use this stuff in the real world. So we'll look at some more of that the next couple of days here before we quiz up on it. Okay? We'll do that starting tomorrow. See you then. Bye.